Struggling with math? You're in the right place. Welcome to Explaining Mathematics, the channel where we simplify tough problems, break down complex formulas, and turn confusion into clarity. From basics to advanced topics, we explain it all step by step. Let's start solving.
It's kind of invisible, but holds our entire modern world together. It's this fundamental rule that makes sure every calculation, from how your bank account works to how a bridge gets built, gives us one single reliable answer. We're diving into the order of operations, which is really the backbone of algebra. Okay, so let's jump right in. We think of math as this super precise thing, right? One question, one answer. But what if that wasn't true? What happens when a single, simple-looking problem could give you two totally different results? So take a look at this. 8 plus 3 times 2. Seems pretty straightforward, doesn't it? But, believe it or not, depending on how you tackle this, you can end up in two very different places. So what do you think? Is the answer 22 or is it 14? And this, right here, perfectly shows the problem. If you just go from left to right, you get 8 plus 3 is 11, times 2, that's 22. But if you do the multiplication first, you get 3 times 2 is 6, and 8 plus 6 is 14. This is what we mean by mathematical chaos. We absolutely need a rule book.
And thankfully, we have one. To solve this exact problem, mathematicians all over the world basically came to an agreement on a single, really elegant system to make sure that everybody, everywhere, gets the exact same answer from the exact same problem.
And that system is the order of operations. Now, here's a key thing to get. This isn't some law of nature, like gravity. It's a convention, a powerful and necessary one. And there's a logic to it. More complex operations, like multiplication, which is really just a fancy way of doing repeated addition, get handled before the simpler ones. It's a strict hierarchy designed to get rid of any confusion. Honestly, the best way to think about it is like grammar for math, especially for algebra. Just like grammar tells us how to put words together to make a clear sentence, the order of operations tells us how to put numbers and symbols together so an expression has one and only one meaning. And the acronym you probably learned in school to remember this grammar is PEMDAS. It lays out that whole hierarchy for us perfectly. First, you handle anything in parentheses. Then you deal with exponents. After that, multiplication and division. And you finish up with addition and subtraction. So you might be thinking, great, I know the letters, I'm all set. But hold on. There are a couple of really crucial details hidden inside this hierarchy that can totally trip you up if you're not paying attention. Let's make sure we get them right. So this is the part that gets almost everyone. PEMDAS isn't really 6 separate steps. It's more like 4 tiers. Multiplication and division. They're a team. They have the exact same priority. Same thing goes for addition and subtraction. They're on the same level too. Okay, so if they're on a team, how do you decide which one goes first? The rule is incredibly simple. You just work from left to right. That's it. It's the tiebreaker, and it is absolutely non-negotiable. You have to follow it. And here is a perfect example of why that rule matters so much. Check out 24 divided by 6 times 2. The wrong way to do this is to do the multiplication first, maybe because m comes before d in PEMDAS. That gets you 2. But the correct way is to work left to right. 24 divided by 6 is 4, and then 4 times 2 is 8. Look at that, a totally different answer. All right, you ready? Let's put everything we've just talked about together and solve a slightly beefier problem. We'll walk through it step by step, using our full PEMDAS hierarchy. Okay, first thing we do is scan for parentheses. Don't see any. The next item on our list is E for exponents. And yep, we've got one, 2 to the power of 3. So 2 times 2 times 2. That's 8. Our expression just got a little simpler. Now we move on to the multiplication and division team. And remember, we've got to work from left to right. So the very first operation we run into is 18 divided by 3, which gets us 6. We're not done with this step yet. We keep scanning to the right for any more multiplication or division. And there it is, 8 times 4, which is 32. Okay, now the M and D team is all done. And look what's left. We're on the home stretch. All we have is the final tier, addition and subtraction. In this case, it's just one simple addition problem. And our final, definite, one and only correct answer is 38. See, by following the rules, by following that hierarchy precisely, we take a problem that could be chaotic and we get one single right answer every single time. So you might be thinking, okay, cool trick for my algebra homework, but it is so much bigger than that. This simple rule is basically the invisible engine running a huge part of our modern world. It's the bedrock for science, for technology, for finance, you name it. I mean, just look at these formulas. This stuff is everywhere. If you're calculating compound interest in finance, you have to do what's in the parentheses first. Or in physics for kinetic energy, that E for exponents means you absolutely must square the velocity before you multiply by the mass. Get that order wrong, and your calculation for how fast a satellite needs to go is completely worthless. This isn't just academic, it's critical. So let's zoom out for a second and just land the plane here. What's the big picture? What have we really learned? Because it is way more than just a 6-letter acronym. The main takeaway is that the order of operations creates certainty where there could be complete confusion. PEMDAS is our guide, but the real trick is remembering that multiplication and division are a team, just like addition and subtraction, and you solve them from left to right. And it's not just a rule for a classroom, it is the hidden language that makes our complex world possible and reliable. And that kind of leaves us with a final thought, doesn't it? We've just seen how one simple, universally agreed upon rule brings order to all of mathematics. It really makes you wonder, what other simple rules, for things like traffic or language, or just in society, are quietly working in the background, keeping our daily lives from falling into chaos? Thanks for joining me.
If this video helped you understand the topic better, don't forget to like, subscribe, and turn on notifications so you never miss a lesson. Comment below what topic you want explained next. Thank you for watching Explaining Mathematics. See you in the next problem.